Okay, can you hear me? Yeah. So welcome back, everyone. From the coffee break, we are starting with our third panel discussion, dialogue and debate, and I'm very happy to be moderating this very exciting group of panelists here debating on rediscovering the past. The past or the history of technology or engineering within the field of engineering is, I would say, rather problematic. The field of engineering is rather 200 years old. It's full of exciting projects and developments. It has helped to build more secure, faster, higher, and wider. But looking back into the long history of building was never really part of that discipline, we can say. And it is today as it was 200 years ago. I remember very well when I started my job in London in a big engineering office, and my job interview was in a meeting room, which was called Christian Menn. The company was very proud to name their meeting rooms according to big engineering figures. So this was their contribution to history. It was said that nobody in the office actually knew Christian Menn. So there was this, it was a very sad relationship to really be dedicated, to have a certain relationship with your own practice, but at the same time, not really having this with all the people there in their mind. So rediscovering the past is something that we want to discuss about now. That's after all the discussions we had on sustainability, about construction today, problems that we are facing as engineers today. It's surely a new chapter for the conference. It is not so true for the panelists who have actually embedded the historical thinking always in their work. We have three very interesting panelists here. They will share with us their view on how they are actually bringing a critical historical thinking into their, let's say, thinking about their practice of designing in our time today. There's Tullia Iori, Aurelio Muttoni, co-host of that conference, and Jürg Conzett. I will very briefly give you some context about all of them, and then we will jump right directly into our discussion. Tullia Iori is a professor at the Tor Vergata University in Rome. She is a civil engineer. She has provided with her PhD a very important, broad insight into the early development of reinforced concrete in Italy. And she's an engaged expert in journals and juries. Internationally best known for a very big European research project, SIGSI, where they focused on the Italian School of Engineering she led together with Sergio Poretti. Aurelio Muttoni, well known as a co-host of this conference, is professor at the EPFL in Lausanne, head of the Structural Concrete Laboratory, is also an engineer and focused in his PhD and later on reinforced concrete, the co-founder of Muttoni and Fernandez Consulting Office, and is engaged in the FIB, in commissions and task force, and very particularly engaged in the development of the Euro Code for structural concrete. Your Conzett, also someone I do not really have to introduce here, is also a civil engineer. We really have an engineering panel here. Who did not go straight into engineering after being educated, trained as an engineer. He worked several years at the atelier of Peter Zumthor. Since then, he runs his engineering office in Chur, works very closely with leading Swiss architects, and is considered one of the most important bridge builders in Switzerland. He's also engaged in the cultural heritage, as he was committed many years as the president of the Society of the Art of Engineering Structures in Switzerland. So we will ask the question, rediscovering the past, in which way can we actually recognize the value of the past? How can we actually make use of it? How can we embed it in our design thinking today? If you talk about conceptual design thinking today, we will recognize that concepts can be new, but many problems are very old. And it makes sense to remind us regularly, actually, that there are very brilliant references and ideas around that we can always turn to. We will again have inputs, statements from the three panelists here. I will then directly open to all of you. We can elaborate on those talks and then having a broader discussion at the end. So I invite now Tullia Iori to give her input.
So, I would like to tell you a story, 3 stories, short stories of 3 engineers who live in the 19th century, in the 20th century, and in the first century of the new millennium. The first story is the story of Charles, from his diary. I was born in 1810 in France. I attended the École Polytechnique, the best engineering school in the world at the time. My professors were Cauchy and Navier. Navier taught masonry bridges, and he was obsessed with suspension bridge. I wasn't interested in these bridges. They seemed to me medieval, like drawbridges. Instead, I wanted to build bridges for railway, the new fast way of connecting places. I admired the Stephensons. We completed the first line in 1830. As soon as I graduated, I moved to England, hired by Stephenson, and I was involved in the design team of the Britannia Bridge. I wrote a wrought iron continuous beam, 140 meters span. To understand the behavior, we test a scale model. At that time, many scholars devoted to understand statically undeterminate. What's that? Ah. Okay. At the time, many scholars devoted to understand statically undeterminate structures. The solution of the big question was in plain sight, but only Maxwell understood it in 1856. I moved back in France, and I met that guy, Gustave Eiffel. He was 34 when he founded his company, and he asked me to manage his team of young engineers who studied with Carl Kuhlmann in Zurich. They calculated so fast using a new technique, graphical statics. I didn't understand anything about the theory behind it, but thanks to them, we won all the bids. Meanwhile, steel started to be produced, but Eiffel didn't trust the new material. He preferred wrought iron. In 1883, I received a telegram from the US by Emily Warren, inviting me to the inauguration of her suspension bridge, 500 meters span, the Brooklyn Bridge. The piers were neo-medieval, but it looked nothing like a drawbridge. I was wrong when I was young. Then, in 1890, I went to the inauguration of a stunning cantilever bridge, 520 meters of span in Edinburgh on the 3rd of 4th, a steel bridge. So, also a fail, was wrong. In our century, we knew completely new material, new revolutionary way of calculation, big new challenges. The history of engineer changed completely. I had the best professor of my time, but I have seen things they wouldn't believe. So let's move to Giulio's story from his diary. I was born in 1900 in Italy, in Rome. When I was 10 years old, I saw Risorgimento Bridge being built. The company used a new material, reinforced concrete. Everyone said Ennebick, the inventor, refused elasticity theory. A German engineer checked the calculation and sentenced that the bridge should collapse, but the bridge did not collapse. I still walk on it each Sunday. I fell in love with this stubborn material, concrete and steel together, joined in a marriage. It was so easy to think about this solution, but nobody did it before Ennebick. I graduated an engineer in 1924, Reinforced concrete was still little studied at the university. I was hired by a guy, Pierluigi Nervi. He was addicted to reinforced concrete. He founded his construction company when he was 30 years old, but in Italy. Mussolini had taken power, and he didn't like reinforced concrete. He preferred the materials used by the ancient Romans. In 1936, Mussolini banned reinforced concrete in the name of autarky. He said, we had to build with stone and brick like Romans. What madness. Fortunately, Nervi didn't listen to him. He invented a new way to build structures and a new material to save steel. After the war, putting together the two inventions, he built domes 100 meters in diameter using ferroconcrete and structural prefabrication. He became the most famous engineer in the world. The fascists forbidden him to use his favorite material, and without complaint, he found a new way. In the meantime, I escaped to Switzerland. I was Jewish and I couldn't stay in Italy. There, I met Colonnetti. He, too in exile, he taught everyone a new technique he learned in France, pre-stressed concrete. By pre-compressing concrete with steel cables, the concrete gained tensile strength. Again, it was so easy to think about the coaction, but nobody could do it before Freycinet. When the war ended, I worked with an exiled fellow, Zorzi. We designed dozens of pre-stressed concrete bridges together, my second life. When I retired in Rome, there was a young visionary engineer, Musmeci. He built a bridge in southern Italy using a soap bubble as a model. He tried to use finite element methods, a strange method of calculation that 4 guys invented in the US in 1956. Calculators will come soon, Musmeci said. He couldn't wait. Everything changed during 20th century. New materials, new way of building, new calculation method, new social challenges. Luckily, my professors taught me to be curious, not to be afraid of change and crisis. Good teachers. Now, the last story. Neo Jane from her diary. I was born in 2000 in Botswana. While I was attending university, the pandemic arrived. During the curfew, on internet, I could attend university courses all over the world. So great. I did my PhD in Singapore. In the second half of the 20s, the world knew the birth of United States of Africa. Africa was extremely rich, full with rare earths, the new oil. In Cape Town, now the most important engineering university in the world, a new construction material was produced, starting with 2 rare metals, dysprosium and thulium. Thuliumed dysprosium, the material of this century, stronger than steel and more beautiful than silver. After graduation, I was hired by Elon Musk, the richest man in the world at the time, born in Pretoria. We built hyperloops all over Africa. We designed the road, and then the robots, the KUKA ones, assembled the structure on their own. No accidents, no errors, no strike. We built also a hyperloop bridge over the Straits of Gibraltar, 13 kilometers span, to connect United Africa to Europe. In 2056, trying to understand the behavior of rare earth structures, Sharbat, an Afghan professor, understood that elasticity does not exist. It's only an apparent effect of a more complex theory. Hanebik was right. Like when Einstein explained that Newton's gravity force was only an apparent force due to the curvature of space-time. Sharbat was in exile in Switzerland. After the return of the Taliban dictatorship, she was a woman expelled from the university, like the Jewish during fascism. And then I stop. You'll be the ones to tell the true story. I would sell my soul to the devil to see this timeline filled now. What's the moral of my fictional tales? Don't be afraid of innovation. New materials, new system of calculation, new technologies, new challenges. Don't be afraid of crises like this one, because crises are always an opportunity for innovation. And more, be an engineer of your time.
Thanks very much, Tullia. Are there any questions immediately? What do you want to know about the future from Tullia? Anyone? With this projection that you have made from 19th, 20th century into the future, where do you see the challenges that we are facing as engineers, but also architects, drawing that line? What would you say are the main challenges ahead?
Well, I have not the crystal ball, this is clear. But I think that history can give you a vision also of the future. And it's true that, well, we talk about creativity and conceptual design, but in fact, maybe the real changement in the history, we have seen it during big crises, big changement. So railways change completely the way to build bridges. Railway is the real new in the 19th century, because you have to produce bridges which are really different from the other, from them you made before. And during the 20th century, the war, the Second World War, which was an incredible war, no? We have no idea. In Italy, everything was destroyed. And the engineers were really involved in the life of the society, and they had an important role. And this connection also with architecture, Nervi was an architect and engineer, but in fact, this connection became after a need. You know, they have to do something in that moment, You have to be, you have to be clear what's around you, because around you, there is something different from Nervi's situation. No? Nervi's Italy doesn't exist anymore. Everything changed, but it's true that what we expected for the future is a big changement. It's inevitable. In 1856, Maxwell understood the complexity of structures and the input, something that consent to us to solve the undeterminate structure. In 1956, we have the FEM famous paper by the four from US, and in 2056, I suppose that could be a big changement also in our idea of what's the elasticity, what's the behavior could be. So you have to understand that the 2056 it's now. So I would like a promise by you. In 50 years, we will organize another conference here. You invite me. I will be here like an hologram, maybe. I hope that the life of a woman could be longer, because I will be 102 at the moment, but I will be like an hologram, and you have to explain me what's happened in this century. You, because me, I have not the crystal ball. So this is not to answer to you, in fact. It's completely
visionary enough for any question from the audience? Yes,
you have no Thulium dysprosium? No one wants to know what Thulium dysprosium is?
Hello, thank you very much for this presentation, because in a very short time, you make a very compact presentation, which shows really how important is the profession of engineer for humanity. And I would like to ask you, unfortunately, we see in some countries, maybe including Switzerland, that our profession loses its value due to the responsibility, the conditions of the salaries, and the fact that there are other professions which seem to be more interesting for the young generation, because somebody who is at the age of 17, 18, and who will make his decision, if he's not a romantic like us, maybe he will not choose to become an engineer. And my question is, are you seeing also in your country this problem, or are you optimistic, and how you will see what should we do as engineers so that it remains a choice for the young generations? Thank you.
Well, you you have too much expectation from professors. Navier and Cauchy did nothing about what will happen. So we are here for doing our best. Navier and Cauchy may be wrong in a lot of situations, but also the professor by Nervi, of Nervi, well, I can know some of them, but they had strange idea of the future. So really what we can do for you, it's only to create curiosity and really the idea that this is the most beautiful work you can do, because really this is the basis for all of us. But we really don't know nothing about what will happen to you, to the young generation. And I always stay with my students, and I understand that the gap between me and them, it's enormous. They didn't. So now I have students in my class that never seen the collapse of the Twin Towers. For me, it's something that I have and for them it's nothing. So we can't really share something in common, but I have to understand them. No, not they have not to understand me. This is not the question. The question is I have to try to move them to understand that this is a very beautiful work, and but they have at their shoulders a big team of person, Navier, Cauchy, and Neufeld, and Nervi, and Musmeci, and Morandi, and they all are supporting them, but also watching them. So they have responsibilities. They have to be. They have to join the history of structural engineering. So this is your also your future. Big impact.
Big responsibility.
Big responsibility.
Any other question?
Does it work? Okay. A commentary on what Tullia just said, and following the question. I think one also needs to locate engineering in history. The relationship between the profession and urban population changes around the world. In Europe, there is, in the most densest professional environments, there is one engineer and architect every 100 urban inhabitants. In Africa, at the moment, there is one professional every 100,000 people. Over the next 30 years, 80% of infrastructural construction will take place in Africa and India rather than in Europe. And so that creates a pressure which is not simply about uncertainty, but is about the way of delivering services at a much larger scale than ever before. And I think this should also become part of the narrative.
Mm-hmm. Any other comment? I think one important aspect of Tullia's insight was also, I think there's a global issue. We are in a global world, and I think we are facing the same problems in different scales and different places, but also that we have we are shaping an identity, even though we are not kind of developing a large scale. Even in smaller projects around us, we are shaping an identity. And I think it's a very good case. In your Italian case, you always show how this post-war Italian building up the country anew was an engineering task as much as was the image of a new Italy. And all around us with these structures, buildings, bridges, whatever, we have a responsibility for even each little detail than for any large detail. So there's a responsibility with it. I would like to switch to our next speaker. That would be Aurelio Muttoni.
Merci. Okay. So, since I always have been convinced that every project should be the occasion to do a step forward. to develop new solutions or to enhance existing ones, to improve our knowledge. But at the end of the process of developing a new solution or a new project, of course, the project needs to be realized in a reasonable time, in an economic manner. And when I say economic, means in terms of mostly in terms of not only money, but also quantity of materials, and with a reasonable risk. The question is, in fact, is how do we start the design process? Do we adapt well-known solutions, or do we take inspiration from history, from the history of construction? And this is the topic of this morning, in fact. Or can we develop or even invent new solutions? Well, this morning I will just give or present shortly two examples of my activity. I think this is the very first real design that I did when I was a young engineer. It's a footbridge. The task was very simple, to build a footbridge with given abutments. They were already existing, as cheap as possible. This was the clear goal. I started with a bowstring with very simple links between the two cords. And then I saw that if I want to save materials, then it was not sufficiently stiff, and I got too large moments in the upper cord. And then I improved the system, adding vertical elements. It became, in fact, a kind of a Virendel girder. And I saw, and I was not completely happy with this solution. And I tried to optimize and to improve, to enhance the Virendel girder. And at the end, I saw that the best way to do this is to replace the vertical elements by two very thin members. And I saw that in this case, the lower cord can be very thin, and the upper cord just will take the shear forces and the moments. So this was an enhancement, or this was an evolution from the bowstring to the Virendel to something new. And or at least I had the impression that at that time that it was a new system. Years later, I investigated again the possibilities of this system, and I have tried and I have used it for very different applications. And as Philippe Ménétré has shown very nicely this morning, the context is also very important when we design something, and which means that if you take a system in very different context, this system will, in any case, will evolve in different directions. So I use, in fact, the same system in very completely different situations: bridges, footbridge, a railway bridge, roof of a theater. This has been built. A roof of a manufacturing. This has also been built. And I found this is very interesting to see that every system can evolve and can be adapted. And years later, I have seen, in fact, that this system was not new at all. Great engineer, Swiss engineer, Guillaume-Henri Dufour, designed this bridge in Fribourg 200 years ago, in fact. It was a very nice bridge, not built, unfortunately. And this has been designed, in fact, starting from a cable system anchored at the abutments, and just putting a timber structure on these cables. But what you get at the end is very similar. Or another example, and this has been built some years later by a very good engineer in Japan, Kawaguchi. He came to a very similar solution, in fact, but the evolution, he started the evolution from a truss. He just removed some diagonals from a truss, and what he got was exactly the same. And to me, this is clearly shows that we can start from something known, and then we can improve, enhance, and at the end there is an evolution of the original idea. I will switch to the second example. This is a recent one that I did with together with Miguel Fernandez. Here the task was to design a canopy. And with the architects, we had very long discussions where we work with good architects, in fact, very long discussions to build this canopy. What is the best? Is it better to use a grid of beams or to design a slab with holes? And we have tried both solutions, very, very different combinations of these solutions, and we were never happy with these two possibilities, a grid of beams or a slab with holes. And at the end we said, well, we need to invent, well, it's perhaps not possible to invent something, but we need to try to develop something which is completely unknown. And then we said, well, let's start from a slab. We try to understand how a slab works. We have this. We have drawn the shear field. The shear field is a very nice tool. It shows, in fact, how a slab carries the loads up to the support. And then we remove all materials where it is not needed, or even better, and this is the opposite. In fact, we put the material where we need it, along the directions of the shear field. And this is what we did. What you see here, this is just a calculation. This is just a finite element calculation. It shows the shear field, and at the end we have placed the material here according to the intensity of the shear force and according to the trajectories of the shear forces. Well, we had the impression this is something new, and most probably this is not new. In fact, if we go back, and this was clear for us after this design, this is exactly the same approach as done by Nervi 70 years ago, where he designed these ribs according to the principal directions of the moments. What we did is very similar. Instead of the principal direction of the moments, we did it with the shear forces. What does it mean? That in fact, when we want to do a step forward, very often we have to take inspiration from the history of construction. And very often it is in a conscious, but even more often, in my opinion, it is an unconscious manner. Thank you.
Thank you very much, Aurelio, Muttoni. Any questions? Yes, please.
Hello, I'm Cristina Zanini. I have a question about the last words of Aurelio, conscious or unconscious matter. And I think that perhaps the conceptual design is a process like for the artist in the art. So I think that we have to understand that civil engineering design, conceptual design of structure is part of our culture. And perhaps we have to speak more about this word, culture of engineering. And I think that the history is part of this culture.
Yes, sure. When you use Google Scholar, you get a very nice sentence on the shelter of giants. No? And this is in fact what we do when we work as an engineers. We start from the work by Navier, by Cochet, by according if I follow your experience, Nervi, Morandi, Zorzi, Musmeci, and in Switzerland we have many fantastic engineers, and elsewhere, and in every country there are very good engineers that they have developed very nice solutions. And I think that if it is sufficient that we saw sometime 20, 30 years ago a picture of one building designed or one structure designed by a good engineer, we try to understand it, and it will remain in our brain for the next decades. And then when we are doing something, it will come again to our memory, and then we are ready to do a step forward, in my opinion. So what you call culture, in fact, this is culture. But I also think that in order to make it possible, one needs to try to understand the culture. It is not necessary. It is not sufficient, in my opinion, to know the history. It is necessary, in my opinion, to try to understand the evolution, to try and understand what has been done, to try to understand why it has been done in that manner. And then it is much more. And then the strength of this knowledge is much more important and much more useful.
Mm-hmm. Thank you, Aurelio, for a very evocative description of these links between present and past in these two structures you described. And future. I want to ask this question as a teacher, and I wanted to ask for if you could share some of your insights as to the best strategies or your favorite strategies for conveying this knowledge of previously completed structures, and not just on a timeline of history, but conveying knowledge to students that really can be used effectively in the design process. If you could share some insights with us on that.
This is a very, very nice question. Thank you, Paul. In my opinion, it is necessary to show good examples. And as I already said before, it is really necessary to comment and to explain them. Every example has it is a result of different considerations done by the engineer. Why it has been done in this manner? Why did Maillard develop in 1905 the Tavanasa Bridge? And what was before and what was after Tavanasa? Why this Algina Tobel has been done in this manner? And we have an interesting discussion years ago. Jürg, you remember we discussed why did Maillard design this Algina Tobel with this system and the Valchil Bridge in another manner, more or less the same time, because the task was different, because the span was different, because the requirement for the scaffolding were different. And I think it's very important to explain this to the students, which means that then when they have similar tasks, they can not only try to understand what has been done by others, but they can also use the same, not only the same examples, but the same tools in developing new strategies and new solutions.
Any further question? I think otherwise I would like to ask the next speaker to give us input.
Hello, everybody. I want to focus on a footbridge in the southeast of Switzerland. It's a footbridge made of a local stone, and it goes under an existing railway arch bridge. This is the Flam, the railway bridge, an existing road bridge, a new bridge crossing underneath, leading to a path, a transversal arch here, and a very complex terrain with overhanging rocks. This is the bridge during construction. You see stone, you see prefabricated concrete nodes, you see post-tensioning rods with screws. And this bridge has at least two important historic references. One is design, the proposal of a new Devil's Bridge at the Gotthard Pass by Heinz Hausdorff. I think this was the first time when somebody proposed to adapt the post-tensioning technique of the concrete to stone. This is one of the first drawings for our bridge. And post-tensioning stone means you entirely depend on the post-tensioning. If post-tensioning is not there, the bridge collapses. You have no mild steel and things like that. So it's absolutely important to have the post-tensioning inside the bridge. And so I drew movable bearings on the two ends of the bridge. It's stabilized by the transversal arch in the middle, but here you see, here you see a roller bearing. Control the forces. This is the cross section with the transversal arch consisting of 3 stone pieces. And again, to control the forces, you have 2 metal hinges. The drawing dates of January 2020. At the same time, on site, it looked like this. Of course, the trail is closed in winter. But this is the railway arch. This is the abutment of the new bridge. This is really not the right place to construct a bridge with open joints that can move. So I had a problem, and somehow it became clear that we have to lock the ends of the bridge, that we have to create an integral, robust bridge without any bearings. I calculated the structure with a modulus of elasticity of 20,000 megapascal for the stone, a temporal expansion value of 0.67. I said, for the permanent load, we let the end supports move. So you have -20, you have +17, like a continuous girder on two openings. Now the ends are blocked, and I calculate the temperature difference. This is -30-degree temperature difference. And what happens? The moment on the central support more or less disappears. The bridge lifts from the support. Here, it's again around 17 kilonewton meters, but the sign has changed. On the other side, if you have an increase in temperature, the moment on the support increases to -32 kilonewton meters. And here you have +30 kilonewton meters. Extreme big changes due to temperature, but the stresses are not a real problem because the amount of post-tensioning is big. So we discussed in the office among our partners if this may be a strange result, but can we dare to do it? And we thought we have finally not a big choice. We have to build this bridge without bearings with this kind of sensitivity to temperature changes. So the abutments are fixed into the rock now. And a second measure was to have concrete inside the rock. So the foundation in the rock is made of concrete and the natural stone masonry is on the concrete. We never went into the rock with the masonry to avoid having joints, mortar joints inside the rock. So this is how we built it. Now you see the transversal arch is assembled on the scaffolding. And also this is a bit strange, these elongated granite pieces. So we tested it. We put 2 hydraulic jacks to prove design load on this transversal arch. And down there you see a digital measure. And the test went very well. No sounds, nothing irregular. All things went good, but this elasticity exists still. It was the deformation during this test, and the deformations were quite high. So recalculating, we got a modulus of elasticity of 7,000 to 8,000 megapascal, and you can say it's more or less the granite. There are a few joints. Also, the end bearings in steel will not contribute a lot to that deformation. So I can say on one side, this is a good result because these extreme changes on bending moments are not really the case. On the other hand, I was really scared of miscalculating the bridge in such a way, more than 100% difference. My calculations were wrong. And I tried to reassure these results, and I found an interesting article written by Hans Studer. Studer was a famous engineer for working for the Russian railway. He was the designer of the Wiesen viaduct, the biggest span of all the railway viaducts in the Grisons. This was 1908, and in the 1920s, he designed a dam for energy production, and Studer has a protagonist of the new stone movement. He designed that dam out of stone. So this is the stone dam. Consequently, with the interlocking in the vertical sense, so it's really a stone bridge turned by 90 degrees. The interesting thing was he wrote about this dam. He justified the choice of stone instead of reinforced concrete. It was a big discussion at that moment. And then he wrote, we had stone of excellent quality, and compared to the concrete, we have a bigger elasticity, and we have a smaller temperature expansion number. And so this stone building is much more unsensitive to temperature changes than a concrete structure. And then he delivered his figures, what he measured about the stone, and these figures were more or less the same I had seen. And so this was a big relief to say, okay, it seems that what we observed is right. So this was the second historic reference, just a reassurance of myself. So we finished the bridge and we safely could open it to the public in July. The bridge is on the far left. And since then, I'm really concerned thinking about soft granite structures. Thank you.
Thank you, Conzett, for that journey. Any questions from the audience? I suppose there are a few, but no, everybody's too shy. I think what your Conzett discussed, Jürg, you want to share your discussion? It was a
no. It's just about terminology, because he used the term elasticity, and elasticity was used at that time with the same meaning that we will use, we would say nowadays, deformation capacity, in fact. And
it doesn't exist. It's an apparent force. It's a consequence of something else.
Yeah. So, but how it was used in German at that time is deformation capacity.
You can use it.
It opens the discussion about linear and non-linear behavior and the influence of opening of joints. And
now, if I had known about the surprising results, I would have managed the whole thing a bit differently to measure the movement back. But with this instrument, I did not want to touch anything because it's all was a bit improvised. And so now we have to work on that further. That's just an indicator. Reassured by Studer, that's what I know at the moment. But somehow this is inquieting, but it's also, it creates my curiosity about what is the real behavior of these masonry structures on the short and on the long term. And I think we don't know so much about natural stone construction. We have empirically, we know these railway viaducts, they stand good, but as soon as you go a little bit deeper, you have a lot of questions.
Yes, please. The microphone needed here. And yeah.
Thank you very much. How did you find the article by Studer? Had you read it in the past and you remembered it? Is that the way it happened?
I think when I started to work with the first money I earned, I could buy all the volumes of the Schweizerische Bauzeitung from an old architect. It was in 1983, I think. And it is about 5 meters of my bookshelf. And I mean, this is the difference. Today, you all find this digitalized. But if you take a volume and you start to read, and then you found a lot of things more unexpectedly. And so this was my anti-stress program in the evening, just to read books. And so after a certain time, you know a bit where to find. And I knew that Studer built this dam. I knew that there was some polemic discussion, but of course I did not have the exact figures in my mind, but I thought I can try to search there for more information.
That's very interesting because, you know, now we have, I mean, even for us in Canada, I can read every Schweizerische Bauzeitung issue because the Swiss have very generously digitized everything and made it available to the world for free. Thank you to my Swiss colleagues for that. But I don't think I would ever stumble upon that article. I think the fact that you had it in front of you in paper and you were able to browse through it in the evenings as you described was a superior way of acquiring knowledge in that way. It's something to think about, I think.
Was the second question over there? Hey, thank you for your contribution. I want to share some thoughts with you because yesterday I was walking home and I was thinking about the place we are now and about this roof that we have above our head. And probably at the time, it was the most economic way to build this structure. And then again, you came back to the first bridge you built, Aurelio, and you showed that the task was to build the most efficient structure in terms of costs again. So, and then the presentation of Tullia, which was maybe going a bit into the future. And I'm asking myself the question, which will be the structures that we will be nostalgic about our days in the future? Maybe we will see some structures that today are very rational, some flat slabs that we build every day. And maybe in the future, we will feel nostalgic about those structures. What do you think about it?
What can the next generation can learn from our generation?
In any case, you have not to be nostalgic of nothing. You have to study the past, but nostalgic is not the right word. You have to be an engineer of this time. Nostalgic is not word. Huh? Everything changed. When Nervis built, he had some pressure to do something in a special way, and he found the best solution for that moment. In this moment, it's absurd. What he did is not possible. We have no workers able to do this. We have no the same exigence. So you have to be engineer now and here, not in the past. So nostalgic of nothing. Huh? Study the past, yes, not nostalgic.
This is a slight protest.
But, I mean, whatever we do, we are now here. So I think you have the idea of kind of progress. And
changement, not progress, maybe okay, not progress, changement.
I mean, 30, 40 years ago, when somebody built a retaining wall with stones, that was sick. That was against modern engineering. I remember these discussions. In Seoul is an old, great stone viaduct beside a new road bridge, absolutely ugly, but this was honest at that time. And I think we are much more free today. And I don't know what is the structure of the day. Let's just try out things. And maybe this is afterwards that you find out what was reasonable and what was less reasonable.
Now we are in a pop structure moment. So I want to say that this moment is a peculiar moment of the structures. So you are so chance, Jürg. You made some fantastic culture, no, in your country. But in fact, around the world, there is other kind of solutions. And what I see is these things that I call pop structures, structure that you can move everywhere. No, you can build a bridge by Calatrava in Rome, in Cosenza, or in Stuttgart. It's the same. No, these are pop. I mean, like Andy Warhol. No, yeah. You can change the color and you. But this is something that is of our times. So you have to accept also this. No? In a certain sense, it's the time of Instagram engineering. No? You saw pictures of engineers and it's sufficient. No? It's not important that it was built. Maybe render is sufficient.
Perhaps I'm nostalgic because I still believe in progress. And I think it is necessary to believe in progress. And I think that it is necessary to, and this doesn't contradict the fact that we try to understand what has been done in the past to do better in the future. I think we need to differentiate between being nostalgic of the past and learning from the past. Sure. And again, back to the question by Patrick, I think he used the same word, but the question is interesting. The question could be rewarded in asking what can the next generation learn from our generation, or what can our generation learn not should be done like our generation, perhaps.
Mm-hmm. There's a new
question. Do you have an idea? Jürg and
yeah, thank you.
Tullia.
I repeat, my name is Eckhard Haas, and my question goes to Aurelio Muttoni. Today we heard by Niven Kostic and also by Jürg Conzett that testing structures is already once again in favor. It came a little bit out of fashion on bridges, and I'm wondering if this will be common again, especially in with the use of new materials.
Well, when you say Eckhart, when you say measuring, I think the first word I comes in my mind is monitoring. And I think that what has been lost in the last years is learning from the experience of what has been built to understand how our structures behave and how we can do better. I mean, this is very common in several parts of the industry. They do a lot of measurements. For instance, in our cars, there are a lot of measurements which are done, and these measurements will be used as more and more in trying to improve the behavior of our cars. And for sure, in our structures, we will do this for new and existing structures. So this is, I think, this is something that should be done in the future. I don't know if this was the question, Eckhart.
Just a short question to three of you. Don't you think that the history of construction should be taught in the school and to give a culture to our future?
Bravo.
Okay, thank you.
Very short question, very short answer, Philippe. I have tried in the last 20 years to convince my colleagues at the EPFL to introduce a new course on history of construction to civil engineers, exactly in the same manner as it is done in architecture. In architecture, I don't know, they have 4 semesters in history of architecture, and we have 0 semesters on history of construction, and I was not successful. This is my fault, of course.
I want to tell my experience. I teach a course which officially is called Architettura Tecnica, but unofficially is a course of history of structural engineering. So I teach from FL, from before from Galileo, in fact, and to the history of Calatrava. But this was done because I was very lucky, and I had the possibility to change the name of the class, because in Italy, you know, you can teach what you want inside a course which has a name. This is a fantastic thing. This is perfect. You can call the class as you want, but then inside you can put what you want. And it's supposed to that I teach something like roof. Architettura Tecnica 2 is a course for roof and other kind of things, but I teach history of structural engineering since 15 years. The good things is that now I teach to building engineer, but now civil engineers comes to take my classes, and now they ask me in the other university in Rome, you can have a class also, a course also in my university, but I'm alone. So, you know, this is strange, you know, because I had 1 million euros for this ERC research project. We really did a fantastic work, but now after 5 years of study, I'm alone again. So this is not really something that also the people I try to invite to do this, to convince, to also to a passion to this kind of things. Really, other things are more also more of these times, no? You know, sustainability, or maybe the future of a grasshopper are more interesting, no? Not thinking about Nervi and Morandi and Zorzi and Maya. It's old. It's died a lot of time. So this is something that I have to change also in you, no? To be curious of your world, to be curious of your world, because really the history of architecture is something else. To study what Maillard did. It's a fantastic thing to study on the papers. No, you know, in archive, when you read the papers of Maillard, you read this handmade calculation. This is an incredible thing. Please be a student of history of engineering. I'm open to everyone. Please come to me.
Thank you very much for these last words. I wanted just to make a suggestion more, referring to the title of the panel, Rediscovering the Past and getting knowledge from the past. So from the one hand, it's a necessity because we have to deal more and more with existing buildings and infrastructures. But it also a source of inspiration, as Aurelio Muttoni also showed. But one thing seems to me very important, and if you want to learn from the past, you have to go back to the originals, back to what it had been written and drawn at that time. And this avoids, from the one side, a copy-paste operation and to misinterpret what the story was. And we had a very nice presentation about the Sydney Opera House today in the morning that also showed how important it is to go back down to the method, down to the core. And then I believe that the school in teaching can do quite a lot to tell the people to go back to the very original thing and try to understand it and to tell the real story and not another story that's been told by getting back and back to documents that are not the original ones. Thank you.
But nowadays, it's also to be said that the access to this knowledge is much easier than it was 20, 30 years ago. So you said about the Schweizerische Bauzeitung, if you want to know something about Maillard, You go to a periodica, you search in the Schweizerische Bauzeitung, you put the name Robert Maillard, and you have directly all the papers by Robert Maillard in the Schweizerische Bauzeitung. This is fantastic. This is fantastic. And I think that, in my opinion, the young people will do much more this work than we have done in our generation because of this very easy way to get access to this knowledge.
You want to? Yeah, sorry.
Yeah, you're absolutely right. And I just would like to add, for example, the Schrebach Bridge by Maillard, which is the first text-stiffened arch bridge still existing. Today it has walls on the sides. And it was always the story in a first restoration, this wall had been added. Now, in the archive of the power station, a guy from the power station of Weckital, he went to the archive, he found photographs, he found drawings. These walls were there since the beginning. This is interesting. There were great photographs that show for that time, seemingly a very beautiful view of this new bridge. There are drawings with these walls on only one side. So for me, it's clear this was an aesthetic correction of Maillard's concept. And this is new as a fact, coming from the archive. But at the same time, we have the problem that nothing is written about. We don't know what Maillard thought about that. We don't know how this really was installed. Why? No reason. So in engineering history, I think you very often lack sources, and then you have to do a hypothesis. I think a hypothesis is better than doing nothing. But very often I feel cannot go further than what we have, and this is always a selective element. Yeah.
I wanted to ask a question concerning the smaller structures, which yesterday we called practical structures. And I have the impression that in Switzerland we are quite lucky because we produce practical structures where a lot of care gets put in. However, I noticed in other countries where maybe the funds available are more limited, we see more standardized solutions. Like, for example, in Italy, the overpasses, I noticed they're very often all the same without any difference among each other, and maybe not standardized like for the highway in Ticino, which we discussed today, but more like it's always the same thing, which is repeated over and over. And on the one hand, I don't find these kinds of solutions very beautiful. On the other hand, I can understand that maybe the road authorities have more limited funding. So how would you engage with them to convince them that maybe it is a good idea to put more effort in these practical structures and to have more funding available?
Well, perhaps just a comment. I'm not sure that standardized solution is worse than another solution. I mean, there are several overpasses, for instance, in the French part of Switzerland, which can be defined as standardized with these precast elements. I like them very much. I think they have a very big quality in design, very well designed. And we should care for them, in my opinion. And there are other prototypes which are of not of good quality. And at the end, it's just a matter of motivation by the engineer, because a good solution is not more expensive. Typically, is not more expensive than a bad solution, or the difference in cost is very small. And if you find good solutions, it can even be more economic. The two bridges that you have seen before, they have been designed. These were the result as alternative designs together with a contractor. And we had only the possibility to build them because they were cheaper in terms of money compared to the official solution. And to me, this is very important. It would be the wrong message when we say, well, we have money in Switzerland and we can, and for this reason, we can do nice bridges. This is completely wrong. I think, in my opinion, it is even more challenging trying to do something which has a good quality with less money and less resources. I don't know if I have answered to your question, Max.
I think so, yes. Behind you.
I'm Lucas Ingold. I have a question about this notion of progress that came up now 3-4 times. Is it something that is connected to performance? Is it something that is connected to efficiency? Or what are the criteria that at the end define progress for you? It's a question for all three of you. Mm-hmm. And are these criteria always the same? Or yeah, could you bit elaborate on that, please?
Well, we have new challenges, which means that progress is needed because we have tremendous new challenges, and we cannot build as we have done in the past. I strongly believe that our generation has failed because after the oil crisis in '73, it was clear that there was this challenge, and we have done nothing in the last 30 years. And this was a big mistake of my generation. And this needs to be changed, And in order to change, we need progress.
You want to add something to it, Jürg?
Yeah, I have difficulty that criteria vastly change. One example.
Yeah, this was the point I would try to.
I think that there's a common agreement that modern structures are lightweight, efficient, and so on. Now, the road administration had some problems with retaining walls, corroding rebars on the backside. They turned to unreinforced, heavy retaining walls now. It looks crazy in the section. 6 meter high retaining wall, 1.50 meter concrete, no reinforcement. But what do you want to say against it? Probably this is the most durable solution at the moment. Is this progress, or is this a step back, or is it both at the same time?
I think that we have learned how to avoid the corrosion of that reinforcement. And that detail was really very bad, in fact. And we need to improve it.
Yeah. There was another question over there.
In terms of carbon footprint, it's unacceptable, that cannot be accepted that we build such a retaining wall with such a thickness. Or you can do it without cement, perhaps a very little amount of cement. Then we are back to the.
We put some stones into it.
Some stones, yeah. Then you replace concrete by masonry.
Yeah.
We talked about this maybe one time, but in Venice there is a bridge, the most important bridge that is out of the station, which is made in stones, no reinforced concrete, in 1930 from Eugenio Miozzi. And because of the risk of corrosion of the reinforcement, because in the lagoon there is a biggest problem, and the bridge is made of pietra d'Istria, stones, and it's linked with the Munz metal rods inside. Munz metal, it's from naval so from boats. It's used in the naval industry. And this Münz metal gives a sort of pre-stressing to the stones. And I want to show you. And it's so in Venice, you put all the tourists goes on the bridge. They don't imagine that it's the most sophisticated and most also bold bridge in Venice, much bolder than that one of Calatrava, which is stupid things. So easy things, but that one of Miozzi is so interesting. So it was and tradition, but also so innovative, no? Precursor of the pre-stressing. So the constraints in engineering are always a chance and opportunities.
You want to add something, or Hugo Corres?
Thank you. It was very good, this debate. I would like to add one element. History is absolutely necessary. We need to know the history, and we need to give value to the history. But as you said, Tullia, we engineers are engineers in one concept, or in a concept, in a context. And now we have the possibility to reuse all the ideas, taking advantage of the new technology. Now you can cut your stone pieces with a very strict geometry, and you can use the technology to really retry with all of the ideas. And this is another value for me of the history, because now we have a lot of challenges. We need to do many things we today are not able to imagine, but the history put together with the technology we have, which could contribute a lot.
You want to add something to that? Or otherwise, I think I take this opportunity and flip this into a question as a last thought. And I think maybe also with a perspective as a teacher of construction, but also as a construction historian, I think there's a bit of it's a danger of separating history from design. And in a class, establishing a class of history and emboldening basically also this division of we are looking back and then we do something. And I think it's different in architecture. I think you see in many architecture design studios, they're pinning up references all the time and having a class of history. And I think what we should rather try to achieve is teaching how to playfully, curiosity, but playfully use these techniques, strategies, material approaches in a very practical manner. And I was just wondering, could you imagine a way to do that in teaching, but because it's the easiest or the closest way of changing something for a next generation? Could you see something, how to implement this into a thinking of engineering in the future?
Yes, well, I have the experience of giving a class, which a new class that we have started about 12, 15 years ago, which is called Structure and Architecture. And this is a class that I give always together with an architect. And this is a nice occasion, in fact, also to talk about the history of construction. For instance, I have done several years this class together with Roberto Gargiani, which is an historian of architecture. And it was always a debate on projects. And it was an extremely interesting experience. It was a discussion. We took a project, we described this project, And then it was, starting from this project, it was always an occasion to discuss about the history related to not only to this project, but to the technologies and the techniques and the ideas used in this project. And to me, the most interesting part, it is not to describe the history, but to understand and to explain the history.
Mm-hmm. And the strategies behind these kind of things.
And why there is an evolution. Mm-hmm. What are the reasons behind? And to me, this is the most important lesson that can be learned by the students. Mm-hmm. Why there is a change? This then can be easily adapted and for their future works.
Mm-hmm.
I once had an interesting experience when I taught to students, and this example by Hostorf in 1954, this was one of many contributions. Probably this was the bridge project, the most discussed bridge project in Switzerland ever, this Devil's Bridge. And I told the students, take this as a task to design a bridge for that site without knowing the discussion. And then when you have done it, we look at the discussion. There are many different structural types were proposed and discussed. And there's a big polemic. And this was an interesting experience, that they became like part of the discussion 50 years later. And I think these are manners.
Kind of redoing similar design and problems. Yeah. Would you like to add something?
I want to say something completely different now, but he suggested me. Do you know which is the biggest masonry bridge in the world never built? Maybe someone of you knows this. It's normally it's said that this bridge is the bridge on the Adda River on Trezzo. You know this, 72 meters of span. But this bridge doesn't exist in the sense that it was an invention. Invention did during the 19th century. During the 19th century, there was a group of engineers that didn't like wrought iron bridges and wanted to promote masonry bridges. So strong that he invented that in the past, a bridge of 72 meters of span. You can imagine a masonry bridge of 72 meters of span. It's incredible. And they invented it, they designed it, they published it. And they said, well, in the past, we was used to do these kind of things. Now we have forget. No? We have to return to that. Engineers, this is something that happened between a group of engineers. And this is strange because now, maybe it's not, but they don't want it. They didn't want accept iron bridge. And they wanted to say that masonry was better. I invented to say this. Now this is strange. So I don't know if it's linked with all the other things, but sometimes it comes. But try to ask to Wikipedia. You could find the drawing of this bridge. It doesn't exist.
And also the rendering, perhaps.
No, something similar. But it's strange how it changed, no? And some engineers that don't want the newalty of the wrought iron bridges. They want to say that no, it's better. Masonry bridge is better. They were so strong to invent a tradition. This is a question about fake news, which is another in another conference, maybe.
But interestingly, Jürg, you talk about the debate on the Teufelbrücke, which was a debate on progress, in fact. Masonry or concrete, or should we use concrete with stone? Or this was the discussion that
stainless steel.
Stainless steel, yeah. This was in fact this was a discussion on progress. And you were saying exactly the same. At that time, it was also a discussion on progress. We are back again to discussion of some minutes ago.
I would like to thank all of you for your contributions and you for your questions and your curiosity. I think I can invite you for the lunch now.